Okay. So I am just taking one problem that some vector field is there. Some vector field, and the vector field is like this: G is equal to X Z by Y and AX. Okay. And I have to write, so this is a vector field. I have to write it in spherical components. Spherical components. So this is a vector field that is given, and you should know that I cap is also written as X cap, is also written as this AX. Okay.
Yes, sir.
All of them are same. So sometimes these notations are also used. So you have to be very careful. J cap can be also written as Y cap, can also be written as AY. And K cap can also be written as Z cap is AZ. Okay.
Yes, sir.
ठीक है, ये नोट कर लेना जरा. Notations को लेके ना, we have to be very comfortable with all type of notations. So try this to write it in spherical components. So what will be the GR? So if you see, if your G is equal to, how to write this? So suppose the components are like we write na, AX, AY, AZ are components of I cap, J cap and K cap. So similarly, I will write GR as component of R cap, or if in the same notation, how we will write? Let us write in the same notation. AR, बोलिए, plus G theta, A theta plus G phi, A phi. Is this okay? बोलो भाई.
Yes.
Yes, sir.
So if I want GR, what should I do? If I want to write GR. So you see, this is very important. GR will be just the dot product of G with AR. Yes or no? Because like if you write this, understand it this like this. R is equal to xi cap, yj cap plus zk cap. So if you want this component x, it is what? R dot I cap. What is y? It is R dot
J cap.
j cap. What is z? It is R dot k cap. Yes or no? Because जैसे ही you take the dot product, it gives the vector towards I cap. So as soon as you take the dot product towards AR, what is AR in notation? R cap. What is A theta? बोलो भाई. Theta cap. What is A phi? Phi cap. This notation is okay, na?
Yes, sir.
So take G dot R. So it is x y x z by y a x dot AR. Correct? See the dot product in your table, AX and AR. What is that?
Sin
Sin
theta.
theta cos.
So it will become XZ by Y sin theta cos phi. Very good. Who has said this?
Me, sir.
Aruna. Very good. Next one, Aruna, can you tell? What will be G theta?
G of A theta.
GR?
A theta.
No, G theta
G theta, yes, sir.
will be
G dot A theta. G of A
very
theta.
good. G dot A theta. So it will be XZ
X Z Y
by Y
cos theta cos phi.
and A theta
Yes, sir. AX A theta
AX dot
A theta.
A theta. What will be this?
X Z by Y cos theta cos phi.
XZ by Y
Cos theta
cos theta
cos phi.
cos phi. And last one, who will tell? G phi.
minus sin phi phi.
G phi will be? Yes.
G dot
A
A.
phi
XZ by Y and minus
Minus
sine of phi. So can we write the vector now in spherical polar coordinate? The transformation of this vector to spherical polar coordinate? Completely, can we write? Puneet,
yes sir.
can we write the transformation now?
Yes sir.
G is equal to,
So we need
tell
to
me,
write that
XZ by Y sin theta cos phi.
yes sir.
AR plus cos theta cos phi
Yes sir. A theta
A theta minus
minus sin phi
sin phi
A phi.
A phi. So this is the transformation of the vector in spherical. This is very nice question. Very basic. So this is a vector or vector field?
Vector field.
Vector field. Why?
so direction.
Sorry?
Direction.
No. Direction तो vector में भी होता है.
सर ये हर एक पॉइंट पे चेंज हो रही है x
No,
and y.
this is defined in a region, ना? बोलो
Yes,
भाई.
sir.
भाई suppose एक vector है, like this. So is it defined in the region?
No
No.
sir.
But once you have x, y by y, so it is defined in the region. At any point, x comma y comma z, you can find this. So such things are called field. So there are scalar fields like temperature, and there are vector fields like
Electric field.
electric field. There is a scalar field like electric potential. Yes or no?
Yes,
Temperature.
sir.
Those are scalar fields. So they are defined in the region. Concept is clear?
Yes sir.
Yes, sir.
Yes, sir.
Okay. So also convert the x, y also in terms of r quickly. Suppose we don't want x, y, z. We purely want to convert it into spherical. So G will be equal to X is
R
R
sin theta cos
sin theta cos phi. Z is R
R cos
cos theta. And Y is
R sin theta sin phi
R sin theta
sin phi.
sin phi into this. Yes? Multiply it and tell me what is the result. Everybody check this. R cos theta cos phi bracket sin theta cot phi AR plus cos theta cot phi A theta minus A phi. Check this. Are we getting this?
Yes, sir.
बताओ भाई, are we getting this?
Yes, sir.
Yes, sir.
Very good.
सर क्या लास्ट में cot phi आएगा क्या a phi का कोफिशिएंट?
यहाँ पे
यस सर.
यहाँ पे देखो sin phi है,
यस सर.
तो sin phi इससे कट जाएगा
यस सर.
और sin theta इससे कट जाएगा.
ओके ओके सर. यस सर.
तो क्या बचेगा?
सर सही है सर.
ठीक है ना?
यस सर.
So now we can transform na, like in cylindrical also. So homework में लिख लो, transform this vector into cylindrical. Write it in homework. Transform the vector into cylindrical. Now I want to just discuss, if I have suppose R in Cartesian coordinate and it is given by x I cap plus y j cap plus z k cap. This is the value of R. Okay. So if I want to write small increment dr, what it will become? This will be used dx I cap, see in your figure dy j cap and dz k cap. That cubical figure we have made now of dx dy dz. So if a vector dr is taken, so it will have components all along dx I cap and dy j cap and dz k cap. Correct?
यस सर.
ये बड़ी छोटी सी बात है, but it is very important. Now we have to understand three things. First of all, understand it in Cartesian और उसी चीज का फिर ट्रांसफॉर्मेशन हो जाएगा transformation will happen in spherical polar and cylindrical. So three things are three important operations. Three important operations. And these all operations are done using del. What is this called?
Gradient operator or del operator.
Del operator. And this is a vector quantity. Okay. And what? So this is del operator. And actually this is something associated with a differential, right? So this del in Cartesian, first of all understand this in Cartesian, then we will write it for other coordinate systems. It is actually I cap del by del x plus j cap del by del y plus k cap del by del z. This is del operator, so important. And also del square, okay? Del and del square both are used extensively in vector calculus. So this is an operator, so it will operate on some field, okay? So if the first operation is del is itself is a vector and it can operate on a scalar quantity f. F is a scalar. So result will be a vector quantity and it will be I cap del f by del x plus j cap del by del f by del y plus k cap del f by del z. And gradient of a quantity, what it represent? So if f represents some scalar field, what this operation known as gradient of a function. This is called gradient of a function, and gradient of f represents the extremal change, the direction of x. So this will be a vector quantity, and this vector will be in the direction of extremal change of the field f. So it will represent extremal change of field f. So like if f is representing some mountain, so it will grad of f will tell the direction in which the mountain is steepest. If f is representing some temperature, it will tell the direction in which the temperature changes steepest. And if f represents a potential, the gradient of potential will tell the extremal change in potential. So सबसे तेज, सबसे ज्यादा change को represent करता है. Okay. So why it is important, I will give you an example. So ये operation wise it is clear now. It is just operated from here, from this side. So obviously f will be multiplied here, here and here. Okay. So example समझने के लिए देखो जरा. Let us understand. Like electric field is equal to minus of gradient of f, gradient of v. V is a scalar field. So electric field is, this represents, this is a vector. This represents the direction in which the potential increases सबसे तेज, extremist. Okay. सबसे extreme तरीके से potential जिधर बढ़ रहा है. And because of this minus sign, vector will reverse. So what will be the electric field? Electric field will be the direction in which potential is decreasing steepest. Okay. So let me explain you this. So suppose this is 5 volt and this is 0 volt. Okay. So this is the direction in which the potential is changing fastest. So this is the gradient V direction. So this is the direction of gradient V. So this is the direction of electric field. This will be the direction of electric field. Please understand this. This is the meaning of gradient. Yes? समझ आ रहा है?
Yes, sir.
So suppose कोई पोटेंशियल प्रोफाइल है, तो अगर मैं ग्रेड ऑफ पोटेंशियल प्रोफाइल लिख लेता हूं तो मेरे पास एक वेक्टर है जो कि बताएगा कि पोटेंशियल किस डायरेक्शन में सबसे तेजी से बढ़ रहा है. एंड बिकॉज ऑफ दिस माइनस साइन उसका जस्ट अपोजिट डायरेक्शन आ जाएगा, तो ये बताएगा कि किधर सबसे तेजी से पोटेंशियल घट रहा है. तो जिधर पोटेंशियल सबसे तेजी से घट रहा है दैट इज द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड. यस? So please write in a sentence the gradient f points in the direction. Gradient of f is a vector that points in the direction of maximum increase of f. And if you get the mod of grad f, this will give the slope along this maximal direction. So actually, if you get the magnitude of this, so that means the slope of the potential. So del V is like, suppose in 1D I write, so it is del V by del x, right? So del V by del x is what? V और x का अगर ग्राफ प्लॉट करूं तो it is slope, right?
Yes, sir.
Huh? So the slope है, that is the electric field. So that means grad of V represents the slope. So if I take the magnitude of this represents the slope along this maximal direction. So suppose this is a function. So if the gradient represents this vector, so if you take the magnitude, so magnitude will be the slope of this. So suppose this is some f versus x. So grad of f will give you the slope if you calculate the mod of grad f. तो 1D में अच्छे से समझ लो, grad f will be del f by del x. Mod of this will give you the slope. Obviously del f by del x will be the slope. तो 1D में अच्छे से समझ आता है. Is it okay?
Yes, sir.
तो अगर तुम्हें फंक्शन का वो डायरेक्शन निकालना है जिस डायरेक्शन में वो सबसे तेजी से चेंज हो रहा है, सबसे तेजी से बढ़ रहा है, तो क्या निकाल लोगे? ग्रेडियंट निकाल लोगे. You will calculate the gradient of that function. So gradient will be for a scalar field. Grad of scalar field can be calculated. This cannot be a vector because if it is a vector, दो वेक्टर्स के बीच में अगर दो वेक्टर आ गए तो only dot and cross is possible, right? So इसलिए f has to be scalar. Any doubt? अभी मैं मिटाने जा रहा हूँ gradient. Okay. Now the second operation is, because I will now take vector field, so second operation is del dot, suppose अब मैं a ले लेता हूं, f नहीं लिखता हूं, del dot a, where a is a vector. This is called divergence. This is called divergence. This is known as divergence. ठीक है? So divergence of A is a measure of how much A vector, because it is a vector quantity, spreads out about a point. About a point. So this is a measure of how much a vector spreads out about a point. So like if this is a point and this is the vector spreading out, okay, like this, it spreads out about this point. So this del dot A will give you that, it will give you the measure of spreading out about a point. Okay, so what it tells, that if vector is going out of this point or coming into that point, if or not going or not coming at all, suppose all vectors are parallel, okay, so it will tell that. So divergence क्या बताएगा? What will divergence tell?
How much it spreads.
How much it spreads about a point. So I can take some questions where you can calculate the divergence. So let me give you a question. Or I will define curl and then we can do all the three questions, okay? Gradient, divergence and curl. So let me define the third one also. So this is a vector. Del operator is a vector operator. So now the next operation I can do is the cross. So this is called what? Curl. This is what it is known as curl. And del cross A operator, right? It represents, it measures how much a vector rotates, or we can use this word, swirls about a point. Around a point. Okay. So suppose this is the point and is your vector doing like this about this point? Is it swirling around this point? So how much it is swirling is the measure of, is measured by curl. So how much it is going away from this point or coming to that point is measured by divergence, and how much it is swirling about a point is measured by curl. Is this okay?
Sir,
Hmm.
sir, this how much swirling means what, sir?
मतलब कितना, कुछ कोई किसी का कुछ मेजर होना चाहिए ना
अच्छा
भाई,
अच्छा
कम या ज्यादा या जीरो।
ओह
भाई ऐसा भी हो सकता है कि ऐसे निकल जाए वेक्टर इस पॉइंट के अबाउट, तो कोई रोटेशन नहीं है। हाँ,
यस सर यस
और
सर
रोटेशन है तो कितना है, तो उसका मेजर कैसे करोगे, तो दैट इज मेजर्ड यूजिंग कर्ल।
ओके सर
ठीक है ना?
यस सर
So measure of all that is like this. So how it is taken? एकदम जैसे हम A क्रॉस B निकालते हैं, वैसे ही I कैप, J कैप, K कैप, दिस, इसके कोफिशिएंट क्या है? डेल बाई डेल एक्स, डेल बाई डेल वाई, del by del z. And what are the coefficient of A? Ax, Ay, and Az. This is the curl of A. Okay? Like जो electrostatic field है, electrostatic field in electromagnetic theory, उसमें del cross E will be equal to 0, क्योंकि उसमें कोई भी कर्ल नहीं. So this is called irrotational. क्या कहते हैं इसको? Irrotational. So even it is a measure that if del cross E is equal to 0, then that electric field may represent an electrostatic field. Are you getting it? So, I mean, a field due to a charge which is stationary, the field due to this, if a charge is stationary, should be irrotational. That means curl of that field should be 0. But as soon as this charge starts moving with constant velocity, you know, curl of E becomes non-zero because it is minus del B by del T, which is Faraday's law. Faraday's law. So everything will be connected. You can see this. So this case, the electric field is irrotational, but in this case, it is not irrotational. So when magnetic field becomes function of time, then curl of E is not 0. So what are these? These are vectors, no? E is vector. तो ऐसे ए ए करके पढ़ो तो फीलिंग नहीं आती, बट अगर कोई केस ले लो तो वी गेट टू अंडरस्टैंड. बोलो भाई, समझ आया?
Yes.
So तीनों ऑपरेशन ओके हैं. ग्रेडियंट टेल्स a vector which is in the direction in which the scalar function is increasing maximum. किस डायरेक्शन में मैक्सिमम? तो इंक्रीज मान लो हर डायरेक्शन में कर रहा है, बट ग्रेड लेते ही वो डायरेक्शन आ जाएगा जिसमें सबसे ज्यादा इंक्रीज कर रहा है. इज दैट ओके? देन कम्स डाइवर्जेंस विच टेल्स दैट अ वेक्टर, तो पहला वाला तो स्केलर था, दूसरा वाला वेक्टर है. वेक्टर का जो एक पॉइंट से स्प्रेड है, दैट उसका मेजर है डाइवर्जेंस. एंड द थर्ड वन इज द कर्ल which is the measure of the swirl or rotation about a point, so around a point. So this is the measure, this is measured by this curl of A. So जरा तीनों के छोटे छोटे कुछ questions करते हैं. Let us see that the first one is, if a vector r is given, if just r is given, mod of r is under root of x square plus y square plus z square. Okay. So what is this vector? I mean, this is what? This is a
Scalar.
Position vector.
scalar field.
Yes, sir.
This is a scalar field. So what is the gradient of this field? Gradient of R. So R is a field. What is the gradient of this field? So calculate करना. It will be I cap del by del x अंडर रूट एक्स स्क्वायर प्लस वाई स्क्वायर प्लस जेड स्क्वायर. आगे जाके मैं और सिंपल फॉर्मूला बताऊंगा, बट लेट अस डू दिस. फील्ड इज सो सिंपल ना. आर what is this field? It is just magnitude of a position vector, right?
Yes, sir.
Plus j cap del by del y root of xy square plus y square plus z square plus k cap del by del z of same. What will be this? If you take derivative 1 by 2 x square plus y square plus z square to the power minus 1 by 2 into 2x. बोलो भाई.
Yes, sir.
Yes, sir.
Plus j cap 1 by 2 x square plus y square plus z square to the power minus half 2y plus half of k cap x square plus y square plus z square to the power minus 2z. Hmm?
Yes, sir.
So 2 will cancel. So what will be grad of r is equal to, it will be I cap x, and what is this?
1 by r.
If I take it in the denominator, it is just r plus I cap y j cap and plus k cap z by r. So it is what? ऊपर क्या आ जाएगा?
R vector
R.
of r.
What
R
you will get?
mod r.
R by
Mod r.
r vector by mod of r vector, which is unit vector. तो होना भी तो यही चाहिए. देखो कितनी सिंपल सी बात है, बड़ी इंटरेस्टिंग है कि दिस इज आर वेक्टर. यू नो दिस इज आर वेक्टर. एंड यूनिट वेक्टर क्या होता है? आई टोल्ड यू, यूनिट वेक्टर इज द वेक्टर which is
Increasing in the direction of the respective.
increasing in this direction. So if you take grad of this will be a vector that will be increasing in this direction. And वही आ गया देखो. So that's why हम gradient के help से unit vectors निकाल सकते हैं. Because if any vector is given and I take gradient of that, it will tell me the direction in which that vector is increasing सबसे fast, steepest. So because r vector सबसे तेज किस डायरेक्शन में बदल रहा है? r cap direction. Are you getting it or not? Very simple problem,
Yes,
but
sir.
very deep consequence. So if you have any scalar field, I can calculate the direction in which this scalar field is increasing steepest. So I got magnitude of r and I got a vector. So r cap represents the direction. लिख लो. R cap represents the direction in which the scalar field R is increasing maximum. And the
Sir, can you
magnitude
repeat once more, sir?
R cap represents the direction in which the scalar R is increasing maximum. So you have a scalar function and you wanted a direction in which that scalar function is increasing maximum. So you took that gradient of that. And you know that R cap is a unit vector of R position vector. Yes or no?
Yes, sir.
समझ आया?
Yes, sir.
So this is what we expected from this. Suppose electric field is represented by just a vector, not electric field. Just a vector R is represented by xi cap plus yj cap plus zk cap. This is the vector. So what is this function actually? This is 0
Position vector. Yes, sir.
and this is this function, this vector. Bolo bhai. Hello.
Yes,
Yes, sir.
Yes, sir.
This is the vector. So is it going, it is diverging from a point or not? This vector.
yes.
Yes, sir.
Diverging? So let us
Yes, sir.
check. Let us check. We can see it is diverging. So we should get a positive divergence. So del dot R, it is 3. Yes or no? Which is positive 3. Which we can see here. It is diverging from a point. Correct?
Yes, sir.
Another vector, let us take R is equal to Z cap and R is equal to Z cap. Just get the divergence of all this.
First one will be 0. Z cap.
So what is divergence here?
0.
0.
This is 0. 0 divergence. And what about this?
1.
1.
1. So if I make this, this will Z cap is just a unit vector in this direction. Right? What is z
Yes,
cap?
sir. So the direction in which Z is increasing the fastest.
And what is z cap?
The vector field.
So z जैसे ये वेक्टर है, if you take different points x comma y comma z, so for x comma y comma z you have a positive divergence, and for only z cap you have zero divergence, and for z cap you have divergence is equal to 1. If you take the z axis, this is 0 comma 0 comma 0, and what is this? 0 comma 0 comma z. So this is the vector. Okay. And एक का कर्ल भी निकालो जल्दी से.
सर
हम्म.
सर z कैप का मतलब एक एक डिस्टेंस पे यूनिट वेक्टर.
No, z cap भाई. How to plot z cap? So like how you plot r x I cap y. So you take 0 comma 0 comma 0 and then you make a vector, na, x comma y comma z. Then this is a vector.
Yes sir.
Correct?
Yes sir.
So if you plot 0 comma 0 comma 0 and 0 comma 0 comma z, then this is the vector z cap. Okay?
Yes sir. Yes sir. And z cap is only the unit vector.
So z cap is only the unit vector, right?
Yes sir.
So we don't have a point in which
We can analyze.
yeah, we can analyze.
Okay sir.
अब जरा कर्ल निकालना. So let us calculate the curl. So suppose we have a vector A is equal to minus y x cap plus x y cap. Calculate the curl of this field. This is a vector field, na? Vector field. So it will be del cross A is equal to I mean x cap, y cap and z cap minus y x 0 minus y x 0 del y del x del y del y del y del z
Z.
is equal to. So x cap, what we get is
0,
0 minus y cap,
0,
what we get
0,
0 plus z cap
2,
1 minus
1
1 minus minus 1.
1 plus 1.
Yes sir.
So here we get 2z cap. Okay.
Sir,
Hmm.
so if we want to know which point it is rotating.
You can see na that suppose this is a vector. Okay. So you can plot these vectors na by taking different points.
Yes, sir.
You can just take different points and draw the vectors. Okay, let me just plot it. So suppose I plot this. So how you will take? You will take this x. थोड़ा देखने में दिक्कत होगी बट कोई बात नहीं, ट्राई करो. एक्स वाई जेड है.
Yes, sir.
Yes, sir.
So take different values of this, different set of values, and we can draw the vectors. So these vectors, like if you draw these minus y x cap plus x y cap, all these vectors. So you will find for different values, you will find they will be on this plane. XY plane में ही तो होगा.
Yes, sir. XY plane में होगा.
So they will be like this, going like this.
With magnitude 2.
These vectors with magnitude under root x square plus y square. Okay. So in XY plane, ये ध्यान देना, ये ऐसा बनाना मुश्किल है. It is in XY plane, right? These vectors.
Yes, sir. Yes,
So
sir.
किसके about rotate कर रहे हैं?
Z cap के.
Z cap. So that's why you are getting Z cap here.
Okay, sir.
Okay.
Yes, sir.
So ऐसे ही even if a vector is like going this side, coming this side, then also it will be considered to be rotating. Okay. ऐसा नहीं कि बिल्कुल, if suppose vector is going like this and coming like this, and then this. Let me tell you a profile of such vector. Suppose I take a vector A is equal to x y cap. Suppose this is a vector x y cap. Okay. So जैसे जैसे तुम, it is x y cap, so it will be in the direction y. हाँ.
Yes,
और
sir.
जैसे जैसे x के पॉजिटिव में जाओगे तो वेक्टर बड़ा होता जाएगा, और x के नेगेटिव में जाओगे तो वेक्टर दूसरे
छोटा होता
डायरेक्शन में
जाएगा.
बड़ा होता जाएगा. नहीं, दूसरे डायरेक्शन में बड़ा होता
Okay.
जाएगा.
Yes, sir.
तो ऐसा लगेगा कि इस तरफ से जा रहा है, इस तरफ से आ रहा है. तो इसका कर्ल निकालना जरा. टेक द कर्ल. Take the curl of this vector.
K cap.
Hmm?
K
Curl of A is what?
K cap.
Z cap. So if you draw the vectors, so जैसे से x के पास आओगे, वेक्टर का मैग्नीट्यूड थोड़ा होगा. बोलो भाई. Because it is depending on x ना.
Yes, sir.
और जैसे से दूर जाते जाओगे, it will become bigger.
Yes, sir.
और
Yes, sir.
दूर जाओगे, it will become bigger. And if you change the side, like एक plus x axis है, एक minus x axis है ना on this plane. Can you see that?
Yes, sir.
Yes,
This
sir.
is not like this. This is like this. So if you come this side, they will reverse the direction. But still, when you are close to x is equal to 0, they will be small. and when you go further they will become larger, and when you go more further they will become more larger. So it will be also considered to be rotating. Can you see that it is going like this?
Yes, sir.
भाई ऐसे ये भी तो रोटेशन है कि तुम ऐसे गए और ऐसे वापस आ गए. But measure में this is more rotating than this. Yes or no? So that's why इसका curl का 2 है and that is only 1. So that's why curl represents the measure of swirling. Measure of whirlpool. Okay?
Yes, sir.
चलो, thank you so much. फिर आगे discussion करेंगे. Thank you.
Thank you, sir.
Any
Thank you,
doubts?
sir.
Anybody wants to ask anything?
Sir,
Yes.
sir,